folks, so we did quiz 1, right, which was uncertainty and simple measurement. Now we have a conservation of mechanical energy quiz. Now the questions of interest, right, again there are two versions of this quiz, right? These two questions serve as question 1 on each version of the quiz, and then these two questions, 4 and 5, serve as question 2 on the quiz. So number 1, let's do this. What is the total mechanical energy of the helicopter provided it has this mass? It's cruising at constant speed at an altitude of 200 meters. Now here's what you do. To get the total mechanical energy, right, total E, okay, you have to do half mv squared plus mgh. Okay, so you have to do half times 1,000, okay, times 25.0 squared plus 1,000 times 9.81 times 200. Okay. Once you work this out, you'll get an answer. Make sure you're at the right number of significant digits. What I would do is I would probably put this at I would probably put this at 3 significant digits, even though this really only has 1 significant digit and this only has 1 significant digit, really. Anyway, or actually they have infinite number since it's exact. Anyway, so I would probably do 3 significant digits because of this guy. That would be my answer. So put this in 3 sig digits. Okay. So that's the first guy. What about number 2? A pebble rolls off a building and falls vertically. Just before it reaches the ground, the pebble's speed is this much. So it's off a building, right? And it rolls off. It initially has 0 rest velocity, right, in the vertical, right? So in the y-axis, it has 0 rest velocity. But we know just before it reaches the ground, its velocity is actually 15. Right, or its speed rather. Now, the height of the building, all of the energy initially should be in gravitational potential energy, and all of it should be completely converted into kinetic, right? So basically, your initial energy should be the total gravitational potential energy, which is mgh, and that should be totally converted into your kinetic energy. Okay. Now, what's awesome is that mass isn't given in the question, and that gives you a hint that the masses need to cancel, right? So h should then be v squared over 2g, right? So it should be 15, 2 significant digits. So leave your answer in 2 significant digits, calculate it, and off you go. Please do not forget your units, right? Your unit will be meters, okay? Over here, for number 4, a roller coaster starts from rest at the top of an 18-meter hill, as shown in the figure below. The car travels to the bottom of the hill and continues up the next hill that is 10 meters high. How fast is the car moving at the top of the 10-meter hill if friction is ignored? That's key. If friction is ignored, then total mechanical energy is true. It's half mv squared plus mgh, right? 1 and 1 equals half mv2 squared plus mgh2, right? Now, if it starts from rest at the top of this hill, right, the initial velocity should be 0. Now, another thing to note is that these masses are canceling, right? Cancel those masses to make life easy for yourself. Next, I want you to notice another thing. The height initially, h1, right, is equal to 18, right? So h1 is given. What you have to find is this v2. So I'm going to isolate for v2. Got it? So what I have to do, if you isolate, you'll get g h1 minus g h2, okay, equals to v2 squared over 2. Okay, work that out. What I can do is I can take out a common factor of g in these terms. horrible. Okay, common factor. Then I can multiply both sides by 2, right? And then I can square root to get my final answer. Simple as that. So that's my equation for V2. All I have to do is plug in the two H's. H1 is 18, H2 is 10, G is 9.81, and you would need 2 significant digits in your final answer because of this guy. 2. Okay? Next, you have a block of mass M is released from rest at a height R, right? So it's at a height R, and it's released from rest, okay? Acceleration due to gravity is obviously G. The block slides along the inside of a frictionless circular hoop of radius R. Find an expression that gives the speed of the mass at the bottom. So it wants the speed right here, okay? But at the height over here, right, H is 0, okay? So it has an initial height equal to R, a final height equal to 0. It falls from rest, right? You see that? So V1 equals 0. V2, I don't know. I got to figure out. So I can use my conservation of mechanical energy once again. It tells me the mass M, tells me G. There are no numbers. Notice that. What it wants is an expression for the speed in terms of the rest of the variables. So don't be scared if there's no numbers, right? You're not supposed to calculate. You don't need a calculator for this particular question. So it is mg, okay, h1 plus half mv1 squared, conservation of mechanical energy, mg h2 plus half mv2 squared, okay? Now I can kill all the masses, all of them. And furthermore, I know that v1 is equal to 0. So this term goes away. So and h1 is r, and h2 goes away because h2 is 0. So this goes away. And so what I end up getting is that gr, right, is equal to half v2 squared. Okay? So that means, right, that I'm just going to call this v, right? So that means that 2gr, okay, equals to v squared. Hence, v equals the square root of 2gr. Okay, and that's your answer. That's your quiz 2. Thank you so much. Have a good one.